and I just didn't dig that like barking orders type stuff. Yeah. Yeah. Yeah, it's, you know, I don't know. I didn't dig that. So let's see. Mic is on. We're recording. Okay, so look, guys, dry your eyes because this is the last section I'm going to teach you for the semester, and some of you forever. So let's see. Don't be sad, but this is it. Okay, so last section now, 10.3 talks about parabolas. And so I know it's been a little while for some of us. Kristen, when was the last time you had, when did you have college algebra? Do you remember? Oh, so a year ago. And Jennifer, do you remember yours? Fall semester, senior year. You said it's been like 7.
Whatever the pandemic started.
Okay, spring 2020? 20 was the last time you had it? Okay. Okay, so it's been a little while since some of us had college algebra, even a year sometime, you know what I mean? Like, what did you do last weekend? Who knows? Okay, so parabolas, just in case you forgot what they look like, for the most part, y'all, parabolas, at least what we studied in college algebra, parabolas do this stuff. So they go like this, right? And this parabola opens upward, and then sometimes we have parabolas that look like this, and these parabolas open obviously downward, right? Yeah, I'm gonna show you all that kind of good stuff. And then this point right here, y'all, and this point right here is what we call, yeah, the vertex. That's that point there, and that's that point there. And then let me ask you a question. There's going to be a number. Oops. There's going to be a number in our parabolas, and it's this number a. When the number a is bigger than 0, I want you to think about like back in maybe even 6th grade, when you would draw the number line, right? And anytime they drew the number line, the number they always put in the middle was 0. Think about numbers that are bigger than 0. Numbers that are bigger than 0 are to the right. What kind of numbers are those? Positive numbers. Okay, so when it says a is greater than 0, it just means it's positive. When the number a is greater than 0, that means the parabola opens up. When a is less than 0, which are negative numbers, oh, come on, 10, which are negative numbers, that's when the parabola opens down, okay? So that's basically what a parabola is, okay? What we have here, y'all, in 10.3 is, and if you notice right here, I'm going to see if I can get my pen working again. Here we go. Okay, so the equation is y equals ax squared plus bx plus c. A is not 0, it's a parabola. And look what it says. It's upward if a is greater than 0, meaning a is positive, and it's downward if a is less than 0. Okay, so it says a parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. So it says the line perpendicular to the directrix passing through the focus is what we call the axis of symmetry. And the vertex of the parabola is the point of the intersection of the parabola and the axis of symmetry. Let's see. It says a point P, which has coordinates x, y, is on the parabola if D1 is equal to D2. Where D1 is the distance between the focus and P, and D2 is the perpendicular distance between P and the directrix. What's going on, Jason? the distance between the vertex and the focus of the parabola is what we call the focal length, and is often represented by the absolute value of p, 10. There we go. Okay, so what I want to point out here, and I'm going to bring this up, and then we're going to zoom in a little bit. So these first two right here is basically like the kind of stuff that we did in college algebra. We figured out how to graph those kind of problems. In pre-cal, y'all, we're also going to look at parabolas that either open up to the right, or when parabolas open up to the left. Okay. So we're going to see if we can kind of figure out what's happening here. We have a couple of equations. These equations here, y'all, and I'm looking at these two, this one here and this one here. These are when the vertex is the origin. So remember when we did the ellipses and when we did the hyperbolas, we did those when they were centered at the origin, the vertex was at the origin, and then we kind of ventured out when they weren't, okay? So let's take a look and let's see, we're going to do some stare and compare stuff here. And then we have something called the length of, see if you can say it without laughing. The lattice rectum is called the focal diameter and is equal to the absolute value of 4p. The endpoints are -2 times the absolute value of p and p, and 2 times the absolute value of p and p for parabolas that open up or down. And similar kind of thing here for parabolas that open left and right. Okay, so it says we're accustomed to writing the equation of a quadratic function with vertex at the origin in the form y equals ax squared. The benefit in writing it in this form, x squared equals 4p, is we can identify the value of p, which gives us the distance between the vertex and the focus. The focal diameter is given by, again, they got it right here. Okay, so first thing we're going to do here, it says, given a parabola defined by y squared equals 8x, find the focus and the equation of the directrix. Okay, so the first thing I'm going to do, y'all, I'm going to write down the equation that they gave me. Y squared equals 8x, and I'm looking for the focus and this thing called the equation of the directrix. Okay, first thing I'm going to do, I'm going to look at that equation, and then I'm going to scroll back in my notes up here, okay? And I'm going to ask you a question, and I'm going to write down the equation that we had, which was y squared equals 8x. And does it look more like, why don't we call this one here number 1 and this one here number 2? Does the equation that we have, does it look like it follows more like 1 or like 2? Yeah, like 2, right? Okay. So we're going to do a little stare and compare. We're going to put y squared equals 4px, okay? Just like we were doing before when we were solving systems of equations, remember we would do like the substitution method? So look, y'all, we can say, look, if y squared equals 8x and y squared equals 4px, we can say that 4px is equal to 8x. We can cancel out our x's, which is going to tell me that 4p is equal to 8. So that's going to tell me now that, hey, p is equal to 2. Okay? All right. What we're looking for, I'm going to scroll back down to my problem. What we're looking for is we're trying to find the focus and the equation of the directrix. So look, the focus is going to have coordinates. It's going to be a point where the coordinates are p and 0. And in this case, our p value is 2. So I'm going to come back over here. I'm going to say, look, my focus is 2, 0. And then we want to find, missed the C here, the directrix, right? So when I come back over here, the directrix is going to be x equals -2, right? Okay. X equals -2. What I'm going to do, y'all, I'm going to draw that line. X equals -2 is a vertical line that does this right here. And the point 2, 0 is right here. Okay. Now, I'm going to show you something, y'all. There's some information that we have right here. There's something called the focal diameter, okay? I want to explain what the focal diameter is. Remember this here, y'all? I'm going to put that point in green. That's the 0.20, and my vertex here is the 0.00. Y'all agree with me that the distance from here to here is 2 spaces? Okay. What we're going to do is we're going to, from the focus, y'all, we're going to go up, not 2 spaces, but double that amount, okay? So look, if I go up, not 2 spaces, but 4 spaces, 1, 2, 3, 4, do you see how we're hitting a point on our parabola? And from the focus, if I go down, not 2 spaces, but double that amount, okay? Can anybody tell me, what do you think the coordinates of that point would be? And what do you think the coordinates of that point would be? Let's do the top one first. What do you think the coordinates of this 2, 4? Good. Okay. What about the one on the bottom? Not negative. Excellent. Good. 2, -4. Okay. Now, what I'm going to do this with a green dotted line. Now, guys, I'm just doing this so that you can kind of see what's happening here. But I did a little green dotted line because I want you to notice something. Right underneath our problem, there's a little paragraph right here, and I kind of edited the notes yesterday and realized that I did a little layout faux pas there with that line. But it says to determine how wide to graph the parabola, determine the length of the line segment through the focus perpendicular to the axis of the symmetry with endpoints on the parabola. This line segment is called the lattice rectum. That dotted line, that's our lattice rectum, okay? These here, y'all, are the endpoints. The way I find that lattice rectum, remember we said, the first thing I said is, look, from my vertex to the focus, what is that distance? We said that distance was 2. What we do is we double that distance, but instead of going from the vertex to the focus, we go from the focus up and from the focus down. And that's how we can find those endpoints. Does that make sense? Okay. So, I don't know, but trust me, a few weeks ago when I was doing this, I was like, oh my God, how many laughs are we gonna get in class? That's what I said. See if you can say it without laughing. Well, we're all adults, but you don't have to be adults. Yeah. Oh yeah. Yeah. All right. So let's take a look at the next one here. It says, look, graph x squared equals 16y. We're going to identify the vertex, the focus, the focal diameter. We're going to find the endpoints of the lattice rectum, and we're going to write equations for the directrix and the axis of symmetry. So look, let's do this. Yeah, x equals 16y. And so the first thing I'm going to do, y'all, I'm going to scroll back up here to the very top. And like Jennifer says, this is going to be more like number 1 because it's in the form x squared equals 4py. So what I'm going to do over here is I'm going to put x squared equals 4py, and then we can set this piece equal to that piece. So we're going to set 16y equal to 4py, so we can get rid of our y's. So 16 equals 4p. Everybody agree that means p is going to be equal to 4? Okay. All right. So now that we found that, I'm going to go through my problem here. It says, first thing we're looking for is the vertex. Well, the nice thing about these couple of problems here, y'all, the vertex is at the point 0, 0, right? These are centered at the origin. Let's go back and find the focus. So if I come back up here we go. Look, our focus is in the point 0 and p. Okay. So the focus is the point 0 and 4. Okay. We're going to look for something called, we found the focus. We're going to find the focal diameter. So just to give you a heads up, it's right here. This is how I find the focal diameter. It's given to us by 4 times the absolute value of p. So I'm going to call this the focal diameter is 4 times the absolute value of p. So this is 4 times absolute value of 4. Everybody agree that's 16? Okay. because the absolute value of 4 is still 4. Okay, so let's take a look here. First thing is we're going to put our vertex at the origin. So here's the vertex at the origin. And our focus, y'all, is the point 0 and 4. So look, I'm going to go 1, 2, 3, 4. Okay. All right. Yes, 0, 0 right here in the middle. And then my focus is the point 0 and 4. Okay, so the next thing we're going to do, y'all, is see how the focal diameter is 16? That means the focus, y'all, is kind of like the point in the middle. It's the midpoint. And the whole segment, y'all, is going to be 16 spaces wide in this case, okay? So if this point is here, if the point 0, 4 is in the middle, and the total distance is 16, wouldn't that mean from here to here would be 8, and from here to here would be 8, because the whole thing has to be 16? So this is what we're going to do. From this red point, y'all, we're going to move 8 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8, right about there. And I'm going to move 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8, right there. Okay. Now what I'm going to do is with my black pen, I'm going to draw my parabola, and it goes through those endpoints. So look, I'm going to put these points in black since they really are points on the parabola. That's the point 8, 4. That's the point negative 4. 8, negative 4, I'm sorry. I'm going to do this in green, just kind of like the way we did before. This here, y'all, this little line segment, that's the lattice, okay? And so that's the part that we're saying, hey, that's the line segment that is 16 spaces, right? 16 spaces in length. And let's see, what else do we need to find? So we found, identify the endpoints of the lattice rectum. Hey, we did. Those are those points right there. Write equations for the directrix and the axis of symmetry. Okay, so let's do the directrix. Okay, so I'm going to scroll back up here. Let's see, where's our directrix? Here we go. Look what it says. Y equals negative p. So I'm going to come back over here. It says this is y equals negative p. So in our case, it's y equals a negative 4. So that's 1, 2, 3, 4 right here. It's that line right there. And our axis of symmetry, I'm going to do this one in blue. Okay. What does the word symmetric mean to you? What do you think of when you think of symmetry? Equal on both sides, like a mirror. So today, when you left your house, you probably took a quick look in the mirror. And if you're standing in front of the mirror, and say you're 5 feet away from that mirror, then your image looks like it's 5 feet backwards, right? So the axis of symmetry is just a line that cuts the graph in half. And it's this line right here. It's the vertical, in our case, it's a vertical line that passes right through the vertex. And so this is going to be, come on, pen. It's the vertical line x equals 0. And that is our axis of symmetry. Let me put this here. Like this, boom. Axis of symmetry is x equals 0. All right. What do you think? Parabolas, at least the ones with the vertex at the origin, are they making sense so far? Pretty straightforward. They should be. Even you guys, even the next two where they're not, the vertex is not at the origin, they're still going to be pretty straightforward on how to do it. Okay. All right, let me get some water, and then we'll move on to the next part here. Okay, so here we go. Another problem similar. It says graph 3y squared equals negative 36x. Identify the vertex, the focus, the focal diameter, and identify the endpoints on the lattice rectum and write equations, again, for the directrix and the axis of symmetry. Okay, first I'm going to do 3y squared equals a negative 36x. So actually, before I get started, though, I'm going to divide everything by 3. Y squared equals a negative 12x. Okay. And the reason why I'm putting it like that in that form there is I'm going to come back to the very top. Y squared equals negative 12x. And we're going to do a little stare and compare. And we're going to say, hey, does y squared equals negative 12x? Does this part here look more like 1 or 2? It looks more like 2, right? Okay, so it's going to be where the axis of symmetry is at the x-axis. Okay. So let's see. Y squared equals 4px. Okay. Let me come back over here. So y squared equals 4px. So we can say 4px equals negative 12x. So we get rid of those. So 4p equals negative 12, which tells me that p equals what? Negative 3? Okay, so now let's see. The vertex. We know the vertex is at the point 0, 0. Let's see if we can find the focus. So again, when I scroll back up here to the top, y'all, let's see. The focus is in the point P0. So the focus is going to be the point, what? Negative 3, 0. Okay, so look, first thing I'm going to do, in black, I'm going to put my vertex. In red, because the focus is not actually on the, on the parabola itself. Negative 3, 0 would be 1, 2, 3 over here. Okay. All right. So again, remember what we said before? The distance from the vertex to the focus, in our case, it's 3 spaces. So what we're going to do is we're going to go double that amount up and down from here. So I need to go up 1, 2, 3, 4, 5, 6, right up there. And 1, 2, 3, 4, 5, 6, right about there. I think that's 6. Let me make sure I counted right. 2, 3, 4, 5. Ah, I didn't count right. Okay, there we go. Okay, and let's see. So, oh, we need to find our focal diameter. Remember, the focal diameter, y'all, is 4 times the absolute value of p. So in this case, it's 4 times the absolute value of negative 3. The absolute value of negative 3 is 3, so 4 times 3 is 12. So my focal diameter in this case is the number 12. So we found our vertex, we found our focus, we found our focal diameter. We want to identify the points of the lattice rectum. These are these points right here, y'all. Okay. So let's think about it this way. Remember, this here is at negative 3. So this should be at negative 3 and 6. And this one here should be at negative 3 and negative 6. Okay. All right. So how we're going to graph this, remember, it passes through the vertex, and it's going to pass through those endpoints. So our graph is going to look something like this. Okay. Since my focus is right here at negative 3, 0, my directrix line is going to be x is equal to positive 3. 1, 2, 3 right here, and it's a vertical line that goes like this. Okay. And then our axis of symmetry, I'm going to write this over here on the side. Is the x-axis like that, which is y is equal to 0. And there's my parabola. All right. So we got a couple more to do, so let's take care of these, y'all, and then we will be done. John, am I good here? We're good? Okay. All right, so look, y'all, we're going to do this now. Just like we did before, now we have standard forms of equation parabolas, except now it's at a particular point h and k. So it's not at the vertex. I mean, it's not at the origin. It's just at a, some random point. But just like we did before, y'all, I'm going to call this one here number 1. I'm going to call this one here number 2. And the first thing we're going to do is when we look at our problem, we're going to do a little stare and compare. We're going to try to figure out, are we at number 1? Are we at number 2? And we'll figure it out from there, okay? All right, so here's our problem. It says, graph the parabola, identify the vertex, the value of p, focus, focal diameter of the parabola. Okay, so I'm going to look at this equation that I have right here. Y minus 5 squared equals 8 times x plus 2. And I'm going to ask you a question, and I'll write it over here. We have y minus 5 squared equals 8 times x plus 2. Does this equation here look like it's in form 1 or form 2? What do you think? 2, right? Looks just like number 2. Okay, so first thing we're going to do, we're trying to find the value of p. So again, y'all, if I do a little stare and compare here, 4p is going to be equal to, in this case, 8. So that tells me that p is equal to 2. Okay. So I'm going to come back over here. So we know that our p-value is 2. We also want to find, in this case, we want to find our vertex. Now, y'all, the vertex is in the point h and k. And I'm gonna just, since we have some room here, I'm going to write out the equation so you can see what I'm looking at. Y minus k squared equals 4p x minus h. Okay. Now, when we did the ellipses, we kind of did the same thing. But so I just want to kind of remind you, remember, y'all, whatever signs I have inside here, I'm going to change them when I'm finding my vertex. The thing to remember is the number where the x is, that's the first coordinate for your vertex, and the number where the y is, that's the second coordinate of the vertex. So what's our h and k in this case? Anyone know? So look, here's the h. So actually, remember, we got to, there you go, very good. -2 and 5, that's my vertex, right? Okay, so here's my vertex. And so first thing we're going to do, y'all, we have the vertex, we have the value of p. We need to find the focus. Okay, so let's see how we're going to find our focus. Okay, so I'm just going to scroll back to where we were. And since we're number 2, our focus, y'all, is going to be this point right here. H plus P and then K. So it's in the form H plus P and then K. So we already said our H was a -2. Our P value happened to be a +2, and our K number is 5. So my focus is going to be the point 0 and 5. Okay. And then we need to find the focal diameter of the parabola. Okay, so let's do that too. Let's find the focal diameter. Okay, remember the focal diameter, y'all, is 4 times the absolute value of p. So it's 4 times the absolute value of 2. Well, the absolute value of 2 is still 2, so the focal diameter is just 8. Okay. Okay, so let me show you what we're going to do. We are going to plot the vertex. So the vertex is at the point -2 and 5. So -2 and 5 would be, I'm going to zoom in a little bit just so I can see this a little bit better. Just like that. Here we go. -2 and 5 would be 2 spaces to the left, and then 1, 2, 3, 4, and 5 up. Okay. So there's my vertex. My focus, y'all, happens to be the point 0 and 5. So that's the point 0, 5 right there. Okay. Yeah, my focal diameter is 8, John, because it's this is the formula that I use. It's 4 times the absolute value of P. P in our case was 2, right? Okay, so remember what we're going to do, y'all. We're going to find the endpoints of that lattice rectum. So we know that the focal diameter is 8. Just like I said before, think of, I'm going to draw a line segment that's going to go up and down, passing through the focus. And the total distance of that, the total length of that line segment, y'all, is going to be 8. If the total length of that line segment is 8, and this is the middle point, doesn't it mean I need to go up 1, 2, 3, 4 here? And 1, 2, 3, 4 right there? I'm going to put those points in black. Okay. So, I'm going to ask you a question. If my focus was at 0, 5, and we just moved 0, 9, because we moved 4 spaces up, and then this one here would be 0, 1 right there. Okay, y'all look, now what I'm going to do, I'm going to start connecting my dots. That goes like that. That goes like that. There's my parabola, right? Okay. Part B said identify the points of the lattice rectum. We did 0, 9, 0, 1. Graph the parabola. We just did. Okay. Now it says write equations for the directrix and the axis of symmetry. Okay. So remember, y'all, the axis of symmetry is the line that cuts the graph directly in half. Y'all agree with me that this line right here, I'm doing it in green, cuts that line in half, that parabola in half? Okay, so the axis of symmetry, y'all, in our case is y is equal to 5. It's going to pass right through the vertex in the focus. Okay, and now we need to get an equation for the directrix. Okay, so let's come back. Let's take a look here. Directrix is x equals h minus p. Okay, so it says x is equal to h minus p. So our h value, we already said, was a -2, minus our p value, which was 2, x equals -4. And it's this vertical line right over here. That line right there. Tell me, John. Make sure you got it all. All right, y'all. So we got, looks like we got one last problem, and here it is. Okay, we're going to do exactly the same thing before we did for this one. So let me actually do it like this. Oh, where's my notes? Here we go. Let me see if I can do it this way. This is the piece that I want right here. I'm going to copy that, and let's come back over here. There we go. Okay, so here's the next problem, y'all. We're going to there we go. We're going to identify the vertex, the value of p, focus, focal diameter, all that kind of good stuff, right? Okay, so I'll tell you what. Let's do this one in blue. We're going to look at the equation we have here. X minus 1 squared equals negative 4 times y plus 5. Okay, so I'm going to come back over here. I'm going to write down the equation we had. We had x minus 1 squared equals negative 4. I forgot, what was it? Y plus 5. Okay, so I'm going to ask you all a question. This part right here, the first one, good. Okay, so we're going to say that 4p equals negative 4. So p has to be equal to negative 1. Okay. And then we want to see if we can find the vertex as well. So remember, y'all, we're looking for the point h and k. The h is with this one, the k is with that one. So the h is always with your x value, and the k is always with your y value. 1 and negative 5. Excellent. Okay. So before we go on, are we all good with y1 and negative 5 and why p is negative 1? Jason, we're good. John, we're good. I'm just checking. Are you good on how we came up with p is negative 1 and our h and k are 1 and negative 5? Okay, just double checking. Okay, so let's come back over here. All right, so we said our vertex was 1 and negative 5. We said our p-value was a minus 1. So we want to find a couple things. We want to find our focus. So let's see if we can find the focus. I'm going to come back up here, y'all. My focus is going to be in the point h and k plus p. Okay. So focus is the point h and k plus p. Yeah, h and k plus p. H and k plus p. Okay, so let's see. Remember, this is h, this is k. So my focus is going to be the point 1 and k, which is negative 5, plus p, which is a negative 1. So it looks like our focus is at 1 and negative 6. Okay, next thing we're going to do, y'all, we're going to find the focal diameter. So remember, the focal diameter is always 4 times the absolute value of p. So it's 4 times the absolute value of negative 1. 4 times 1 is just 4. Okay. Okay. So next thing is it's asking us to identify the points of the lattice rectum. So the first thing I'm going to do here, y'all, actually, is I'm going to draw, because I didn't put it on here, I'm going to draw an XY axis just so that I know what's happening. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, and 7. Okay, so we said our vertex was at the point 1 and negative 5. I'm going to do this in green. 1 and 1, 2, 3, 3, 4, 5. Okay, so here's my vertex, right? Our focus is at the point 1 and negative 6. I'm going to do my focus again in red. Okay. All right. So remember, y'all, focal diameter in this case is 4. So what does that mean? That means I'm going to have a line segment that's going to be horizontal, going left and right. And the total width of that line segment is 4. And if that red point is right in the middle, then that means I need to move 2 spaces to my right from here, 2, and 2 spaces to my left from here, 1, 2. Okay. And I'm actually going to do those points in black because those points, oh, I'll do it in green since I was using green. I'm going to do those points in green because those points are actually going to be where the parabola passes through. It's 2 spaces on each side, right? Because since my focal diameter is 4, that means that the length of this line segment here, John, is 4 spaces. But the red point is in the middle. Oh, yeah. So now what I'm going to do is I'm going to go like this. Here's my parabola, right? Okay, and now what we want to do, y'all, we want to find these endpoints. So I know I kind of did this by hand, so this is freestyle. This is 3 and -6. And this one here should be -1 and -6. Okay, so we got our endpoints. We have our graph. I believe the next few things are going to ask us for the axis of symmetry. So remember what the axis of symmetry is. It's the vertical line, in this case, that cuts the graph directly in half. So in this case, this is going to be at x is equal to 1. And then the other thing we're looking for is the directrix. Okay. So let's see if we can find the directrix. I have a feeling it's going to be, in this case, y is equal to -4. So let me double check. Come back over here. Directrix, y equals k minus p. Okay, that's the formula. So the formula is y equals k minus p. What was our k value in this case? Our k was a -5 minus our p was the number -1. So minus and minus become plus. So yep, y equals -4. I'm going to zoom out so everything can be seen on there. But we got it. Huh? What's up, John? Okay. Excuse me. So y'all, the homework for 10.3 is already open, and I'm just gonna pull up the what we have in the weekly activities folder over here. Let me see if I can find it. Here we go. For week 15. Okay, so homework, y'all, is due by next Monday. Okay, so you got a whole week to get it done, and I want to say, y'all, for 10.3, there's like 4 questions. Okay, so you got plenty of time. Let's see. The review for Alexel is set up. So there's 44 questions on the review. Guys, we're going to be able to review this Wednesday and next Monday. And so I'm going to pull up the announcement that I sent out earlier this morning. Let me pull it up so y'all can see. I don't know if y'all have already had a chance to look at it or not. let's see, 8 of us did. But here's the announcement. Okay, so the review is set up. Let's see. So guys, we're going to be able to review this coming Wednesday and next Monday in class. I already made the final. 22 questions, y'all. 22 questions. So what did I do? I took half of those. The 44, I just took half of it. Every question you're going to see on your final is coming directly out of that review. What I did yesterday afternoon, even though it was Sunday, and let me stop recording this real quick because we are already done with all this business here.